All right, center of gravity. So the question on this part is how to explain it. We have talked about little g as being constant so far, but it turns out it's not, and the gravitational acceleration actually can depend on where you are relative to a larger body. If you go far enough above the surface of the Earth, the value does drop off, and it drops off quite a lot if you go far enough away. So if we're really talking about a really, really tall structure like some enormous building, then in point of fact, g at the top will be less than g at the bottom. So that is partly related to what we're running into here. Alright, so center of gravity. You have some object. It's made up of essentially lots of little masses, but there will always be some point that is the center of gravity. And you can imagine that all the mass is concentrated at this point. For finding the net torque. Due to gravitation. Okay. So we'll make a copy of this and we'll come on down and we'll, that's weird. How did I get that? I just did a copy paste. Let's try a second time. Control C, Control V. Well, it worked this time. All right. So we've marked our center of gravity. Oops. And let's set up a coordinate system around this. We'll have a 0, 0 somewhere. And then what we can do is think about each little piece dm has a vector r going to it, and we can start calculating the torque due to each small piece, like say piece 1, would be equal to r1 times or cross mg1. Okay, and we can add up all those torques and it will give the net, which will be equal to the total mass times g at that center of gravity cross product with r for the center of gravity. Let me mark the r for center of gravity. Okay, so this is a bit of a mess. I'm going to rewrite this second half so it's clear. I forgot something. One moment here. There, now I should be able to delete. Alright, so RCG cross M total GCG. Alright, let's actually add all of those up. What will that look like? Well, it's going to be a sum from I equals 1 to whatever number we want to go to of Ri cross Mi Gi. Okay. And we're trying to figure out what RCG is going to look like. So, let's regroup this a bit. I equals 1 to n of MI RI We have to keep it this way for right now. GI RCG cross M total. Okay. This is what you'd actually have to go through in order to figure out the center of gravity. You'd have to basically divide by M total and the averaged center of gravity G. But if G is constant in our region of space, then we can shortcut this quite a bit. And we'd have sum from I equals 1 to n of mi ri cross just our regular old G and our CG would just become the same old G we're used to. I'm going to divide through by M total. And now we have sum of I equals 1 to n mi ri all over sum of mi, which is equal to our M total. Oops. And then we have across G equals RCG cross G. And I think you can see what's happened here. This thing is something we already know. This is actually R of the center of mass. So we have R of the center of mass cross G is R for the center of gravity cross G, which means the location of the center of gravity is equivalent to the location of the center of mass if G is constant. If G is not constant, it gets shifted. So for the building up here, if we really were thinking about things carefully, if the center of mass was right here, then technically the center of gravity ends up being just a slight bit lower than it. But if we can make the assumption that gravitational acceleration is constant everywhere, which we can do as long as we stay at relatively constant elevation, then the center of gravity and the center of mass are co-located. And that's all we really need to know for the current chapter on statics. The center of gravity and the center of mass are generally the same thing, unless you are dealing with very, very large structures. So something like the Burj Khalifa Tower, the Petronas Towers, any of those really tall towers, it's entirely likely that the center of gravity is as much as a centimeter or two, possibly, below the center of gravity. That'd be very slightly different. And if you had structures that were multiple kilometers long, especially going upward away from the Earth, you could in fact get the center of gravity significantly different from the center of mass. But it's not a normal situation. So we will not worry ourselves about it at all in the current chapter on statics. Just remember the location of the center of gravity and the location of the center of mass will be the same thing. Alright, that's it for this, so see you in the next one.